This skateboarder represents part of Newton's first law of motion, which states that an object at rest will stay at rest. This is because the only two forces acting on him are gravity, which is pushing up, and normal force, which pushes him down, but they equal out and result in a net force of 0. This clip also helps to demonstrate Newton's first law of motion because the skateboarder is in motion and remains in motion until there is an unbalanced force, which is demonstrated by the skateboarder's foot causing the kinetic friction to the left, which demonstrates the unbalanced force. These next couple of clips display the use of friction, which is the contract force that acts to oppose sliding motion between surfaces. The skateboard's foot and the tail of the skateboard both make contact with the ground and oppose sliding motion with the ground. Therefore, they represent friction between the skateboard and the surface. This snowboarder does a great job of displaying a constant velocity. He is not speeding up or slowing down and is always going in the same direction. Velocity is defined as a change in position divided by the time during which the change occurs. A projectile is an object that is moving and the only force acting on it is gravity. Therefore, these next couple of snowboarders represent projectiles because there are no strings attached and they are only affected by gravity. There is no normal force or friction or any other forces acting on the snowboarder. The path that the snowboarders are in is known as a trajectory, which is in the shape of a parabola. Here are a couple more examples of snowboarders as projectiles. The gravitational potential energy of an object is equal to the product of its mass, the acceleration due to gravity, and the distance from the reference level. As a snowboarder moves farther away from the earth, energy is stored in the snowboarder because of the gravitational force between earth and the snowboarder. It now has the potential to gain kinetic energy, which one can see in just a second. Kinetic energy is energy resulting from motion, and as the snowboarder leaves the helicopter, it begins to lose its gravitational potential energy and begins to gain kinetic energy as the snowboarder falls toward Earth at 9.8 meters per second in the downward direction. If the snowboarder's mass is 72 kilograms, and since he is free-falling, his speed is 9.8 meters per second squared, he would have a total kinetic energy of 352.8 joules. A snowboarder making contact with the snow and ground after jumping out of the helicopter demonstrates Newton's third law of motion because it states that for every action there is an equal and opposite reaction. In this case, the snowboarder clearly exerts a force on the snow, but the snow also exerts a force on the snowboarder. In this same scene, there is also an example of acceleration. Acceleration is the rate at which an object's velocity changes. So as the snowboarder lands and goes down the mountain, his velocity increases, and this means he is accelerating. This scene incorporates Newton's second law of motion, which is also known as the law of acceleration. Let's say the net force acting on the snowboarder is 180 newtons, and the mass of the snowboarder is 72 kilograms. The acceleration of the snowboarder will be 2.5 meters per second. This shopping cart pushes a great example of work. Not work like a job or career, but work that has to do with physics, which is the product of the force and the object's displacement, in this case the shopping cart. Let's say the two kids are pushing on the shopping cart with a force of 20 newtons and it travels 15 meters. Therefore, the work on the shopping cart is equal to 300 joules. Do you want me to show